Hi, Assalamualaikum warahmatullahi wabarakatuh. So, recall that in the previous video, you have seen how this question is answered. For example, how can you guess the value of this function when t approaches 0? And in order to do this, or in order to guess the value of this function, what we did is we list all the values of t such that the values here get closer and closer to t equals to 0. So the values of t that you are seeing now on this table here are getting closer and closer to 0. So that's the idea of guessing the value of this function here. But the problem with this approach is it is a tedious approach. It takes so much time, and that is why in this video I'm going to introduce to you guys the idea of limit laws, which can be implemented in order to find the limiting value of any given function. Okay, let's look at the rules given here. Suppose that c is a constant and we have two functions here defined as fx and gx, and we assume that both functions here have limiting values when x approaches a. So for the first rule here, let's say that you are interested to find the limiting value of this combining functions where fx and gx are being added together. So what you can do is, in order to solve this, or in order to get the answer to this one, what you can do is you can start by evaluating them separately. For example, you can go on and evaluate what is the limiting value of this function when x approaches a, and then you will go on and evaluate what is the limiting value of gx when x approaches a. Once you have managed to get the answers to this question here, you are going to add them up together. Okay, so that is the first rule. And of course, if you see here, the second rule here is also similar to the idea in the first rule, except that we have a subtraction process over here. So if you have a subtraction process, this notation carries forward to the process that you have to do on this part. Okay, so let's look at the third rule of the third law. Basically, in this third law given here, you might be interested to find what is the limiting value of the function given as such. So this function here is multiplied to a constant. So c is a constant. So what is the limiting value of this new function here? So what we can do is, since c is a constant, you can consider taking that out. So c is going to be put aside. Okay, so we're going to put aside c, and you are going to start evaluating this function first, which is to find what is the limiting value of fx when x approaches a. And once you got the result, you are going to multiply that with the constant c. Okay, now in a similar manner, the fourth rule here is similar to the second and the first rule, whereas here we have multiplication process. So fx is multiplied to gx, and so in order to evaluate this function here, what we can do is we can evaluate them separately, and then once you got the results, you can just multiply the answers. Okay, in a similar manner, this is a division process. So again, this rule here is similar to the fourth rule, the second rule, and the first rule here, where you can just evaluate them separately and then you apply the division process. Okay, so evaluate them separately, and then once you got the answers, you will divide accordingly. Okay, right, next. Now here we have something that is slightly different. So here we have a function. So fx is our function, and there is an exponent n. So this is a slightly complicated function. And basically, the idea of this, and you can see that the result of this is given by such here. What you can do is you can evaluate the function first, and once you get the answer, you will consider multiplying it n times, okay, according to the exponent given here. So where does this rule come from? So this rule comes from the idea of repeating the product rule. So the product rule is given by this one, okay, rule number 4. Now let us look at this rule closer. Okay, so in the product rule, it is basically saying that you want to find what is the limiting value of the function f(x) times gx when x approaches a. And we know that this can be evaluated by having limit x approaches a fx multiplied to limit x approaches a for function gx. Now, what if we consider, instead of having a different function, we consider having the same function, which is fx. So how is this statement going to look like? So this statement is going to look like this. Limit x approaches a fx. So I'm going to substitute fx into this part, so it's going to look like this. Yeah. And this is equal to limit x approaches a fx times limit x approaches a fx. And I hope you can see that for this part here, we can simplify by writing down fx and you square it. Fx times fx is the same thing as squaring this function here. So fx squared is equal to, now you have the same item here multiplied with itself. So this is just limit x approaches a fx and you square it, right? Now let's see what happens if you extend this idea such that we have repeating values of fx, yeah, repeating values. So let's say we have limit x approaches a and we have fx times fx times fx, and we do it for n times. Okay, so this here we've got n times, and therefore we can write down this expression here as limit x approaches a fx. Well, if you have n times, you can simplify by using exponent. So we will have exponent n at the top part, and this will be equal to, so this one here is similar to this part here. Okay, this one here is similar to this part, and the answer to this is going to be limit x approaches a fx, and you will multiply the result here with n. And this part here and this part here is similar to this one given here. And what you are seeing right now on this part is the same thing which is given here by the rule number 6. Okay, so that's the idea of rule number 6, where basically it comes from the idea of repeating the product rule. Okay, now I'm going to erase this slide and I'm going to talk about the next rule, which is rule number 7. Okay, right, so we are done with rule number 6. So now rule number 7. So what is the idea of rule number 7? Well, basically in rule number 7 here, this is a simple function. This is just a function. Instead of fx, we have a simple function which is x. So basically it means we have fx is equal to x, yeah? So that is what it means here. And if you want, you can consider a different representation, which is y is equal to x. So this is a different representation, but carries a similar meaning. So we all know that if you have y equals to x, it is basically a linear function where you have a straight line and the line passes through the origin. at 0.00, and basically it is saying that the value of x is equal to the value of y no matter what. So for example, if x is 1, the value of y is also 1. If x is, I don't know, here might be 3, the value of y is also 3. If x is -1, the value of y is -1. So we have the same values for x and y. Okay, so now what happens when x approaches a? So let's say a is somewhere here. So this is point A. So x can approach a from right direction and left direction. So if x approach a from the right direction, that means the value of y is going downwards, and it will come to somewhere here. And we know that since y is equal to x, of course at this point this is equal to a. Yeah. Okay. And if x approaches a in this direction, so the value of y is going upwards, and then when it gets closer to a, it will reach this point here, and this point is equal to a. So for that reason, I hope that you can see the limiting value of a simple function, where the function here is just x, okay, it's just x, is equal to a, where a is the value of interest in this case. Okay. Now, how about the rule number 8? So in rule number 8, basically what we have here is we have a function where for this one here, our fx is equal to c. That means it is a straight line, a horizontal line, and if you sketch the graph, it is going to look like this. So this is x, this is y. So fx equals to c, or if you want, you can consider y equals to c. If you like this representation better, doesn't really matter. So now this is at point c. C is a constant, and we have a horizontal line for this function here. So what happens when x approaches a? So when x approaches a, that means you can assume maybe a is at this point. So if x approaches a from the right direction, you can see that the value of y is going in this direction, and it will come here and reach this point. Yeah, this point. And if x approaches a from the left direction, therefore the values of y is coming from this point going to the right, and it's going to come and settle at the same value here, and the value here is equal to c. So that's why we got the answer here is equal to c. Okay. So yeah. Now how about rule number 9? So for rule number 9 here, you can see that this is the combination of having rule number 7 and rule number 6. Okay, so you have a simple function x, but you have the exponent n, so x to the power of n. So the result here is going to be a, and a is going to be multiplied n times. So rule number 9 is just a combination of 6 and 7. Now how about rule number 10? Now rule number 10 is rule number 10 here is similar to rule number 9, except that instead of you have x to the power of n, what you have here is, if I can write it in a different form, it will be x 1 over n. So the exponent here is in terms of fraction. Okay, so if you have 1 over n, the answer here is going to be a 1 over n. Okay, so rule number 10 comes directly from understanding rule number 9. And finally, we look at rule number 11. So rule number 11 here, if you can see, this one can be written in terms of limit x approaches a, and we have a function, a complex function, and this is 1 over n. So rule number 11 has something to do with rule number 6. Okay, I think that's all for now, and I will continue with an example to illustrate the given laws here in the next video. Thank you very much for watching.